Hi, just a quick video here covering how to assign R and S configurations to enantiomeric compounds. The idea is essentially to differentiate between chiral compounds which are the same but are mirror images of each other. One key point you just need to know is that the R assignment is working in the clockwise direction and the S assignment is working in the anti-clockwise direction. So I'll show you what I mean by that by first of all ordering our substituent groups by highest priority around the chiral carbon on each of these molecules drawn below. So we see fluorine's highest priority, then we have oxygen, then we have carbon, and then we have hydrogen. And so you can see we're actually going to be moving in an anti-clockwise rotation here, and so we're going to assign this molecule the S configuration. It's the S isomer. Okay, let's do the same on the right hand side here. Fluorine is highest priority yet again, then we have oxygen, we have this carbon, this methyl group, and then we have hydrogen in the back here. We're moving in the clockwise position, and so we have the R configuration. Nice, it is that simple really. There's just one key thing that we need to know after this, and that's what do we do when hydrogen is not in the back, when hydrogen is not in the dotted wedge here, in the dot, is not dot connected to the carbon, in the dot and wedge 3D visualization of the molecule. And if that is not the case, then we have to flip the RNS assignment. So what do I mean by that? Well, essentially we need the lowest substituent attached to the carbon to be in the back. Let me give you an example. We have a carbon from here attached to our phenyl group. We'll put a methyl group in the back. Then we'll actually have a hydrogen in the front. And we'll just put a hydroxyl group here. Remember, phenyl is just our benzene ring. Okay, well, now it looks like, well, what's our highest priority group here? Obviously the oxygen. Then our phenyl, our methyl, and then our hydrogen. So our hydrogen's in the back here. So it looks like we're moving in a clockwise rotation. So you would automatically give that R assignment. However, as lowest priority substituent, i.e. the hydrogen is not in the back, we have to switch the R/S configuration. Hence, this is actually the S isomer. Awesome. And that's all you really need to know for this concept. You have two enantiomers. If the succession from highest to lowest substituents is in the clockwise position, it's the R assignment, and if it's in the anti-clockwise position, it's the S assignment. So I'm just going to draw two molecules really quickly now and pause the video, try and name them for you. Try and do the assignment for yourself. So here's the first one here, and I'll give one more tricky one here. Okay, nice. Alright, so just pause the video and try and do them here. So the first thing I'll do is, put a wedged hydrogen here. Obviously, remember the rule, it's not in the back this time, so we'd have to switch configurations. So first, highest priority, obviously the oxygen, then our longer chained alkyne group here. There's 2, then 3, then 4. So we'd be moving in the clockwise position. However, we're going to have to reverse it because hydrogen is, our lowest priority group is in the front, not in the back. So this is going to be this configuration. Here, let's look. So the oxygen is 1, then this longer chain with the chlorine and the oxygen attached to it is going to be second priority, then third is the methyl, and then fourth would be this hydrogen group coming out. So again, we're moving in clockwise position, and this will give us our isomer, our S isomer, sorry. S, because we're switching it. Now let's look at the chlorine. So we're obviously chlorine's got 1, then 2 to here because this carbon's attached to the oxygen, whereas this carbon is attached to 2 hydrogens, so it's number 3, and then obviously our hydrogen here is number 4. So again, we're moving in the clockwise position, however reversing it because hydrogen's in the back, and we now have our S configuration. And finally, we have let me get rid of some of this to make it easier. This is S again, and we have our last chiral carbon, hydrogen coming off here. So the oxygen's obviously got highest priority. Then this chain attached to the chlorine and the other oxygen, second priority, third priority, fourth priority. But now we're moving clockwise, and so this is our configuration because our hydrogen is now in the back. So no need to switch configurations here. Awesome. So hopefully this is helpful.